Yeah, thanks for the introduction. And yeah, first of all, thanks for staying out to listen to my talk. And I'm going to talk about Aleo today, give an introduction about what Aleo is, and also show you some of the advantage that Aleo has. So before we start, let's look at the encryption, what encryption enables our existing internet. So look at before HTTP, it is just impossible to have the economic activities on the internet because you couldn't just put on your credit card information on the internet and show to everyone else so that like people can steal your information and do it. But with protocol like TLS, SSL, and it enables lots of economic activities and also enables lots of e-commerce that we are using now every day. And at Aleo, we envision that ZK is going to be the S for the HTTPS, but for Web3 instead, and unlocks more real-world activities. So these are a few categories that I like to show as what is real-world use cases with privacy enabled in a Web3 context. So with privacy, now you can have finance, like real-world finance on-chain. Imagine you are a business or banks, you are handling customer-sensitive information such as their assets value or any business-related confidential information. You wouldn't want to show it to anyone else. So that is one of the reasons that we felt that why we haven't reached the mass adoption for Web3 yet. And other than that, with privacy, we can also put identity on-chain now, and there's a lot of use cases unlocked by just having identity available on-chain, such as now we can do a privacy while still compliance payment. That is one of the big example, and it's also one of the focus that we at Aleo currently pushing right now. And other than that, you can also finally have a real on-chain game where it is just not possible before. So all the on-chain games you are seeing right now, most of them having their game logic off-chain in their server or in their database because they couldn't just put some of the confidential information on-chain, such as, let's say, a coordinate that contain rewards. If you put the information on-chain, or like the first player who gets to that coordinates to get the rewards, and everyone, instead of playing the game through your game client, they can check out the block explorer and see which inputs data they are going to put in order to get the rewards. So, and it hurts the gaming experience. And machine learning and AI, of course, another big use cases. And there are a lot of people worrying about existing AI tools such as ChatGPT and others. They do not handle the customer data well, and they're afraid of data leakage in the future. So having privacy with that using ZK can provide better security guarantees for user. So yeah, before we started, let's go through a little bit of the history of Web3 space. So Bitcoin started this crypto economic security to have permissionless and decentralized ledger possible and enable us to transact real values with that. And then Ethereum taking that as inspiration, taking a further step to make it a programmability layer, such as a world computer, they say. And with that, now we see a lot of different interesting applications, such as DeFi, NFT, and such, spin out from them, and lots of other blockchains taking inspiration from Ethereum to try to solve some of the Ethereum issue right now, which is scalability. So we have seen some alternate L1, and also we have seen some now quite novel approach to scalability issues such as Solana, Aptos, and Sui. And we also see there's a modular scalability, like people trying to make all the stacks modular right now by cutting it into different modules. And then Aleo is one of the first player to provide this programmable privacy. So not just privacy, but programmable privacy. What does that mean? So yeah, so just kind of repeating what I say. So Aleo is the first permissionless and programmable privacy-preserving blockchains. So you can see at the visual right there, not having just one, but having just three together. So Aleo is ZK by design. Yeah, before we dive into what does it mean by ZK by design, let's look at how existing decentralized ledger works first. So at current state of a blockchain, how user interact with the blockchain is first they send a transaction that consists of the application, like the pointer to the smart contract, which smart contract they are calling, giving their inputs plus their signature so that it verifies that it's the owner of the account. Then the nodes re-execute every computation in transaction. Why re-execute? Because that's the only way that all the other nodes confirm that your transaction indeed compute correctly following the smart contract logic. And each transaction you're sending, not only one node computing your transaction, but all the nodes all around the world have to re-execute again. So now you can see there's one problem with it, which is scalability and lots of computational power wasted. Yep, so you can see if the computation is correct and the signature is valid, the state gets updated. So yeah, so having the on-chain execution, you can see there are a few issues with that, which is we have a very limited runtime, just like what I mentioned just now, because all the nodes all around the world have to execute your transaction. That's why they couldn't have a very or unlimited runtime. It's just not possible because if they provide unlimited runtime for you, like there's no other user will be able to send and make their transaction finalized successfully. And also there are some limitations, which is limited stake size and storage too. So, and yeah, you can see the core strength of decentralized ledger is also its primary weakness, which is first, scalability. Scalability is an issue, and also second, because you have to re-execute everything, and to do that, you need to have the visibility of what the input of the user are giving to you, and that is hurting the privacy. Oh, sorry. So at Aleo, we are using a model called ZKSI, Zero Knowledge Execution, to preserve the privacy of user. And how does it work? First, we have we are using ZK Snark, so we have a trusted setup, one-time trusted setup that contribute by like everyone in the world to contribute to the randomness of the trusted setup, and then outputting this private parameter, and the private parameter will be used for every program. We call it program here instead of smart contract on Aleo. And the program taking the public parameter produced by the initial trusted setup plus the application public data that is input by the user plus their private data, execute the whole program, and it will generate a proof at the end. So for the verifier, which is the nodes from the network, what they do is very simple. Just verify a very succinct proof, fixed size, fixed time to them, and then they can trust that the execution, no matter how complex that your program is computed correctly. And by verifying that succinct proof, they can update the state after that. So yeah, so what most of the existing public blockchain using right now is called something like an account-based model. And how they store state in their current design is they store every value that is linked to your public address. That's how they know what kind of value that you have, such as your token value that is linked to the ERC20 token smart contract. And at Aleo, we are using something more similar to UTXO. The reason why we are using a different model is that if we were to use account-based model, the first issue you can see there's no privacy for account if you are using like a mapping with account address as key. If we were to store value that is tied to the user account, everyone still can see that, oh, okay, this value from this contract are from this account, even though they might not see the data of the inputs or the state. So if you don't know yet, UTXO is something like, it's a model used by Bitcoin and also a few other blockchain too. To put it in a more simple way, think of it like cash in your pocket. So like each of us, when we're looking at each other, we don't know how much money or fiat money in our pocket. That's how we achieve privacy at Aleo, like a very similar concept. So just have a look at the account model. How does it work? It's the user sends a transaction that consists of the data plus their signature, and then the global state, which is the network, it takes the your account, the smart contract account, sorry, and plus your user address, update the balance or the storage of according to your transactions. While this is very simple and easy for developer to coordinate and manage states for multiple party, but there's a few problems, right? So it's low skill and high fee. So you can, because updating the state, you have to wait for the first transaction to complete first, then you can only update on the latest state. So that hurts scalability too. And other than that, there's no privacy for it. So let's try to turn it into a privacy model using account-based model. Let's try to turn the value into a commitment, code into predicates, and storage, encrypted the storage too. So you can see while we, as a user, we do not see each other balance or storage right now because they are all encrypted. But then there's no concurrency and there's no privacy for account, like what I mentioned just now. No concurrency because of account mentioned just now too, which is to update the commitment. You have to wait for the latest commitment to be complete first. Then you can update based on the latest commitment. Because if you were to use if you're still using the old commitment, your transactions should fail, because if that is not built in, if that is not handled properly, it will cause, people can just do double spending. So you can see some of the property of this model is now you don't have ledger re-execution already because we are using ZK proof to prove the execution. There's data privacy because everything people can see are just encrypted or just commitment. But there's no account privacy, and there's no efficient state update because of the concurrency issue. The last thing is the concurrency issue. So at Aleo, we are using something called record model. So now owner, his address is encrypted, and he sent a transaction. So a transaction can consist a lot of different transition. Transition, it just means, think of it like a single function call. And every single function call will be proved by a ZK proof. And each transaction can actually call multiple transitions, meaning you can call multiple recurring function and gather all the proof together, batch them, and finally include in your transaction, post it on chain. And looking at the global state, what's the program doing right now is, instead of updating the state according to the user or the program commitment, now every record has its own owner, like in the UTXO forms. And then all the data in the records are all encrypted. It's not shown to anyone. And making state transition is really just about updating your own state. And it does not, because it does not interact with other records, we have concurrency here. So you can see the benefit here is now we have concurrency, and the decentralized ledger will enforce that no record will consume twice by having a nullifier of the record that is being consumed. So with that, now we have all the properties. Instead of just having no ledger re-execution and data privacy, now we also enjoy account privacy plus efficient state update. So this is just a comparison of Aleo with most of the public blockchains. So same thing, we have validator because we have our own blockchain. We have developers developing application on top of it too. But Ethereum, well, it depends on the rollup to provide scalability to user. But at Aleo, we already have this kind of scalability since the very beginning because we are already delegating the program execution to user themselves instead of having them compute on-chain. That's how we achieve scalability since the beginning. So the proof system we are using is called Varuna. It's an extended version from Marlin, if you know. It's an R1CS-based universal and updatable SRS proving system. So yeah, so this is just some other data. It might be outdated. So yeah, just take it lightly. But the essence here is by using Varuna, which is a ZK snark system, we have a very tiny proof and very fast prover, a very fast verifier, plus prover too. So at here on Aleo, we don't have recursion, but we are using something called batch aggregation of proof, which I kind of mentioned just now. Like every transaction has their own proof, and a single transaction is a batch of all the proof into one single proof. So here are some of the stack that the Aleo has. So for developers, we have our own DSL because of a difference in architecture. We have to come out with a new language. And this language is built with the aim to abstract all the complexity to deal with lower level circuit for developers so that developers can focus on what they are building, like what they are already doing best at the moment, which is focus on building the logic of their application instead of spending extra time dealing with the lower level cryptography stuff. And Snark VM is the virtual machine that we use to generate proof plus executing the program. And validator by running Snark OS, which is the node client. They are kind of maintaining the whole system. So Leo, this is how Leo looks like. Transition, we call it transition. Every function, you can think of it like an entry point of the a function. We call it transition, and every logic defined in the transition scope are executed off-chain. Yeah, so I haven't mentioned this yet, but at Aleo, we also have an optional public or optional on-chain execution for developers to use too, because there's one problem with privacy because all the state are only visible to the user themselves. So what if you want to do some computation that involve other states, such as some shared states, such as, let's take AMM as example, such as the liquidity volume that is consists in this program, let's say. So that's why we still need the optional public state for user to achieve more complex computation. And to compute on the public state, we have another scope called on-chain scope. We call it async function, but it's not shown here. It's for developers to clearly separate that what kind of logic they want to run off-chain plus they want to run on-chain. So what Leo does is it takes all the logic defined by developers, compile it down to the intermediate representation on Aleo, which is Aleo instruction, and the AVM, the Aleo virtual machine, takes the Aleo instruction, the compile opcode, and run the whole program execution. So yeah, so this is just another visual to show you how every component works together. So you can see Leo compile the logic into AVM, and the AVM execute, generating a proof plus finalizing the program evaluation if the proof is accepted. So yeah, this is just some comparison with other ZK system that is using different ZK ZK proving system. So like stucknet to verify a stuck proof on Ethereum, because on Ethereum everything is very expensive, especially to run verification, which is a little bit more complex compared to normal normal smart contract logic. So it costs a little bit more. And ZK Sync, because they are using ZK Snark, the size of the proof is, of course, smaller than a stuck proof. So they have lesser cost to that. And the average settlement time, it's really based on because they have to wait for a certain amount of time, or an epoch collect all the transaction, batch all the transaction or all the proof from their chain, and finally settle to the Ethereum, which is settling back to L1, then it consider finalized. But on Aleo, because every transaction has their own proof, and if that proof is verified, the transaction is finalized immediately. So that's the difference compared to other ZK systems. Yeah, this is just some of the data to show how long we have been here. And as we can see from this graph here, there's a lot of improvement in the ZK proving system. So it makes having a ZK application more practical right now. And also another big effort that currently runs by Aleo is that other than the blockchain itself, we also have an incentive for hardware provider or hardware producer, like people who produce the machine or the proving hardware. So in order to incentivize that, we have something called proof of succinct work, where we rewards token, like a Coinbase token rewards to whoever whoever solved the solution of a ZK Snark challenge that we design. So compared to what is currently running on Bitcoin, SHA-256 hashing, it's what we felt that it does not incentivize anything. It just people compete with each other, and it's a waste for all the computational power, because the hash does not give any values. But computing a ZK proof, it indirectly incentivizing people to come up with better hardware to generate the proof faster and more efficient. So you can see this is our token schedule, and you can see there's a big chunk that is allocated for Coinbase reward for this effort, other than validator rewards. And also, because every transaction has multiple proof, at Aleo, we believe we are actually bootstrapping a marketplace, which is we are kickstarting a demand for proof generation, and this making all the proving market possible, because they will be receiving a lot of demand from Aleo, and compared to other blockchain, because the proof generated by the other blockchain themselves are not as much as Aleo, because the proof they are generating are only on the batches of transaction. They are going to post back to Ethereum. But on Aleo, every transaction, they have multiple proof in the transition. So that's how we create a lot of demand for the proving market. And yeah, one of the products that we are also kind of building at Aleo, it's ZPass. It's a ZK identity where people can verify their identity while still preserving the confidential of their information, such as their address or their age. And this is how ZPass works currently. So first, we need to have an issuer public key. There are some attributes in the identification that you want to verify. And then the ZPass issue as a record to the user. And what the user can do is taking that ZPass record, go to any third-party application, generate a proof with that record, proving that it fits certain requirements by the application. And if it fits the requirement, the result will be true, and the proof will be verified as a true too. So compared to other identity solution, we think that the identity solution on Aleo is more streamlined, more modular, and more scalable. So this is one of the example of how we can use this identity, this privacy-preserving identity, which is compliance payment while still having privacy. And because Aleo is a programmable privacy blockchain, so any program that is going to be deployed by the, let's say, some stablecoin provider, they can code their logic arbitrarily. So they can include kind of like a regulation checks or some requirements if you are sending to some high-risk country, and you can program all that thing into the program. And user, by having a ZPass, they can verify that they are actually fits into all the requirements defined by the regulators. And also, what the regulator can do to, or the program deployer, they can also create something called an audit log that is only visible to themselves or any party that is interested in this information. So what people can see on the blockchain explorer, it's still encrypted. Like, it's not shown to everyone else. What everyone can see on chain is just an encrypted version of it, which is the ciphertext. And yeah, and once you finish that track, programmability, sorry, and you can proceed to issue the stablecoin. And yeah, so this is another use cases, ZKML, I kind of mentioned just now. And also we are at a very exciting time. Well, that there are a lot of different ZK projects that are taking different trade-offs in order to provide what they felt the best to the user. And yeah, we are very exciting to be one of those projects too. So yeah, so that concludes my presentation. If you have any question, you can always add me through Telegram and ask me any question. Yep, thank you.